All right, my friends, let's take a look at 2012 problem 3 here. It gives us this fun piecewise defined function. It says let f be the continuous function defined from -4 to 3, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function given by g of x equals the integral from 1 to x of f of t dt. For part A, it says find the values of g of 2 and g of -2. So let's go about it. So since g of x is defined as the integral from 1 to your input value of x of f of t dt, and when you're finding g of 2, it would be at the first piece just as simple as substituting 2 in for x on this side. Like so. And now for looking at what that would mean. So if you look at the picture, since this is the graph of f, we would basically be finding, using the relationship between integrals and area. So really we're just finding the area of the region that's bounded between the x-axis and the graph of f. Since it's underneath the x-axis, we'll get a negative value. So just really quick, checking the equation of the line, it looks like we go down 1, and then we go from 1 to 3, so over 2. So the slope is 1/2, which tells me that when you go over 1 unit, you go down 1/2. So that means that this little distance right there is 1/2. So the area of the triangle would be 1/2 base, which is 1, times the height, which is 1/2. So the area of that little triangle would be 1/4. And then the integral value would be negative since it's underneath the x-axis. So that means that g of 2 would be -1/4. Okay, now for g of -2, that would be the integral from 1 to -2 of f of t dt. And I was just going back to the original definition and using substitution. Now, up to you how you want to handle this. I personally don't like it when my bounds make me think from right to left. So I will use the property where if you switch the order of the bounds, it just negates the value. Okay, so now looking at this, we're going to go from -2 to +1. So from -2 to -1, we have a triangle. Its height is 3, its base is 1, so it would have an area of 1.5, and integral value would also be +1 and 1/2. From -1 to 1, you have the area of a half circle, so you would just use half of a pi r squared where the radius is 1 unit. So that would, you'd end up with 1/2 times basically pi times 1 squared, and it would be negative because, or your integral value, that is, would be negative because you are underneath the x-axis there. So the value here, I'm going to go ahead and carry down the negative, and now we'll just write the value of the integral inside my brackets here. So we would end up with 1 and 1/2, which I'm going to write 3/2, and then plus negative, well, I'll just say minus pi over 2. You're welcome to leave your answer like this. It's not required that you simplify your answers, but I think it looks a little cuter if you either write it like this or like this. There we go. Okay, moving on to part B. Okay, it says, for each of g prime of 3 and g double prime of -3, find the value or state that it does not exist. So let's work on g prime of -3 first. I'm going to rewrite the definition of g. And then I'm going to rewrite this integral in a fundamental theorem of calculus style. So antiderivative of little f would be big F, and then let's plug in upper bound and subtract the value you get when you plug in the lower bound. So you'd have big F of x minus big F of 1, where big F just represents the antiderivative of f. I'm going to bring down g of x. And then remember, if you plug a constant into any function ever, you just get another constant. And I'm mentioning that because we need a rule for g prime of x, which means we need to take the derivative of both sides of the equation to keep your equation balanced. So taking the derivative of big F of x, you'd end up with normal f of x, and taking the derivative of the constant gives you 0, which leads us to know that g prime in this problem is just f of x. So now let's look at, if this is the rule here, what would g prime of negative 3 be? Well, it would just be f of 3, or sorry, f of negative 3, that is. Okay, so let's bring our picture back here. This is the graph of f, so here's negative 3. Since this is the graph of f, f of negative 3 just means what is that y coordinate right there. So let's think about the slope of this line. This line, you would go up 2 and then over 2. So the slope of the line is 1. And so that means that you would go from negative 4, since you went over 1, you'd also go up 1. So you're going to go from 1 to 2. So that means, since this is the graph of f, f of negative 3 would be 2. So f of negative 3 is 2, which means g prime of negative 3 is also 2. Okay. They also asked us for g double prime of negative 3, so let's look into that. I'm going to go ahead and go from this relationship right here. And I'm just going to take the derivative of both sides. So on the left, I'd have g double prime of x. And on the right, I'd have f prime of x. And they wanted to know what's g double prime of negative 3. And according to this rule, that would be just f prime of negative 3. So since this, again, this is the graph of f, f prime of negative 3 would mean the slope of the tangent line to the graph of f at negative 3. Well, f is a line graph in this piece of the graph. And remember, a line graph is its own tangent line. And just a little bit ago, I figured out the slope of that line. It was 1. So we would say f prime of negative 3 is 1. Which means g double prime of negative 3 is also 1. All right, my friends, moving on to part C. Part C says, find the x coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative minimum, relative maximum, or neither a minimum nor a maximum at the point. Justify your answers. I always do my justifications first, so let's go ahead and get started on that. So first I'm going to think about, okay, well, the first thing they asked me, they wanted to know, when will G have a horizontal tangent line? And so let's think that out. So G will have a horizontal tangent line when, and let's just keep it simple, let's just think about G. So that would be when, at any instant, when g prime of x is equal to 0. There you go. And now let's go back, my friends, to, we're going to be looking at the graph of f. So what's g prime, So g prime is f of x. So this whole sentence could have said G will have a horizontal tangent line when, replace g prime with f, so it would be when f of x equals 0. So I'm just going to say AKA when f of x equals 0. There we go. Okay, so now let's look at the graph. This is the graph of f, and we're looking for when f of x would be 0. So it looks like f of x equals 0 here, and f of x equals 0 here. So that leads me to x values of -1 and 1. So therefore, G will have a horizontal tangent line when x equals -1 and 1. Okay, Now they wanted to know at -1 and 1, what does the graph of G have? Does it have a relative maximum, relative minimum, or neither? So let's look at -1 and let's look at the graph here. So also let's think this out. Sorry, I always like to kind of explain first. So actually, no, I'm not going to explain first. We're just going to think this out. Sorry. So the graph of G, let's say I'm surfing the curve of the graph of G and my pen represents the tangent line to the graph of G. So if G prime changes from negative to positive, that means right at that moment when it changed, you'd have a minimum. If G prime changes from positive to negative, then right at that place where it changed, you'd have a maximum. Now, if G doesn't change sign at all, like if it's positive, then 0, then positive again, then you're not going to have a minimum or a maximum value. So, so let's look at -1. G is the same. So let's see, sorry. G prime, so we're looking for what G prime does. G prime is the same as F, right? So at -1, what does the value of F do? It was positive and now it's negative. So that means G prime was positive and then it was negative. So if that means that you'd go from a positive tangent line to a -1. So you'd have a maximum value there. So since G prime, and then I'll just go ahead and say AKA F, changes from positive to negative, at x equals -1, G has a relative maximum there. Okay. Now let's look at the other place where G prime was 0, here at 1. So remember, G prime is F. So since F, aka G prime, was negative on the left of it and then still negative on the right of it, that would be like your derivative of G being -0 and then negative again. So, so that means you'll have neither a minimum or a maximum. So I'll just say, but G prime does not change sign at x equaling +1. So the graph of G does not have a minimum nor a maximum there. There we go. And that's it for part C. All right. And moving on to part D. Okay. Part D says, from -4 to 3, find all values of x for which the graph of G has a point of inflection. Explain your reasoning, and I'm going to go in explaining first. So for part D, let's talk about, the graph of G. G will have a point of inflection when G double prime changes sign. And my friends, this is how you're going to keep the picture problems like this really simple. You're not going to worry about G double prime equaling 0 or anything like that. You're just going to skip to G double prime would have to change sign, meaning you'd have to change from concave up to concave down or vice versa. So, okay, so that's what we're going for. So now let's talk about, well, what's the relationship between G double prime and this graph that we're looking at, F? And remember, back in part B, we had established that relationship. G double prime is F prime. So this sentence could have been written, G will have a point of inflection when G double prime changes sign. And G double prime changing sign is the same as F prime changing sign. Okay, Well, let's look at the graph. So this is the graph of f, so f prime would be the slope of the tangent line. So let's just look for places where the slope of the tangent line to the graph of f changes sign. So you have a positive slope of a tangent line, positive derivative to f here, and then a negative one. So I would include -2. I guess I'll put it down here and circle it. -2 would be a point of inflection on the graph of g. So let's start that list. Therefore, g will have an inflection point at x equals, let's include -2 and then see if we can get some more. So now we have f prime is negative, and then f prime is negative some more, and then now f prime is positive, which would be like g double prime, changing sign at 0. So we're going to include 0. And then f prime, aka g double prime, is positive, and then it changes to negative at 1. So 0 and then 1. There we go. All right, and I believe that's everything they asked for in this problem. I hope this makes sense. I tried to keep it down to basic principles. You are welcome to show your work differently as long as you can explain yourself. Anyway, I hope this helps. Take care, everybody.